Welcome to ePasha lecture series on computer science. In this module on data analytics, we will be discussing about foundations to data analysis, and in this we will be discussing about univariate analysis. The objectives of today's module are to understand the basic statistics methods which may be useful for exploratory data analysis, and in that we will be working towards numerical attributes. We all know that there are three types of analysis: exploratory, confirmatory and then quantitative. Among the three, today we will be discussing about exploratory data analysis. The second objective is to learn about measures of central tendency and dispersion for univariate data. So, what is fundamentally this analysis all about? For that, we should first understand the importance of data measurement. Measurement of data is actually the first step towards proceeding for an analysis, and this is what that decides the outcome of the analysis. So, what is that we need to do is we need to carefully understand what are we measuring, what type of data that comes into picture. Accordingly, a specific type of analysis need to be selected. Only then the outcome of the analysis will be correct. When we are working with respect to data measurement, we need to consider, say, the sampling techniques, how are we controlling the data flow, what type of errors that come into picture because of the various variables that we consider, are they random in nature or are they systematic in nature, and we need to work towards how precise all these metrics and how are they going to affect, say, the accuracy of our final analysis. Therefore, when we are dealing with respect to data measurement, we must be very careful towards what type of data are we correctly handling. Finally, when we have the data, we need to validate. Validation here in the sense, when we are using, say, an automated data collection software or say a tool or a device for collecting data, we need to verify whether the data is working fine. In case if there is some malfunctioning with respect to the device or with respect to the software with which we are collecting the data, we need to validate for its accuracy. Normally, we will be looking in for how precise the device or the tool is, and ultimately we will be working towards the accuracy. Both precision and accuracy will be used for determining the percentage of error with respect to the data collection. This may be visualized both from the perspective of social as well as from physical sciences perspective. Now, when we are collecting data with respect to, say, a data collection tool or with respect to a device, we need to understand what type of data are we dealing with. Fundamentally, this can be classified into two. One is a univariate or a multivariate environment, another one is a cross-sectional data or a time-ordered data. Let us first understand what is univariate and multivariate type of data. Univariate means we will be working with respect to a single variable, and this single variable may be describing the given scenario. For example, it can talk about, say, an individual, it can talk about, say, a place, or it can be anything in the real world. When we talk with respect to a multivariate perspective, we may be using more than one variable. In other words, two or more variables will be used for measuring or quantifying the given scenario. So, when we measure a particular individual, we may be using two different dimensions for analyzing that individual. For example, consider a set of students. We may be using two parameters, one, the percentage of marks they have scored, and the other parameter may be the total amount of hours they have spent towards preparing for the exam. So, now we can analyze, say, the students with respect to their time spent and the percentage of marks they have scored. This is an example for, say, a multivariate data. With respect to a univariate data, we may consider just the percentage of marks scored by an individual in an exam. So, there we are trying to work only with respect to a variable called marks or percentage of marks. Now, with respect to the second type of data, cross-sectional or time-ordered data, normally when we work with respect to a cross-sectional data, measurements are actually taken one at a time, or we normally fix one time period and we collect the data during that time period. But with respect to time-ordered data, we will be measuring the data at regular intervals of time. So, we may fix fixed duration, and in those durations we will be collecting the data. And when we are collecting the data at regular intervals of time, of course, there will be an orderliness associated to the data. So, therefore, when we talk with respect to cross-sectional data, we collect the data and we measure the data at one point of time, but with respect to a time ordered data, there will be some sequence of data associated to some orderliness. Having understood what type of data are, next we should know what are the various types of measurement scales. Measurement scales are of 4 types: nominal or categorical, ordinal or ranking, interval and ratio scaled. We will analyze each and every category in detail. First, let us start with nominal or categorical scale. Say for example, when we take a particular data, assume it is all about an individual. Now, we can assign this individual to a specific age range, or we can assign this individual based on specific nationality, or we can assign this individual say a label that may be based on say his percentage of marks. Now, what we are trying to do here is we are trying to provide either a number or say a categorical label, thereby we quantify that data. This is what is called as nominal or categorical scale data. Here the classification that we do with the help of the categorical label should be mutually exclusive. In other words, every element must belong to exactly one category without any ambiguity. We cannot have any data falling in more than one category. In other words, it will be ambiguous when you are having one data with two different labels. Now, this type of data or measurement scale is considered to be the most weakest among the 4 scales that we earlier listed down. Actually speaking, when you are trying to work with respect to a nominal or categorical scale data, we will have to be very careful, because when we are repeating labels for data, we may end up with a lot of misconceptions. Therefore, we need to be very accurate with respect to nominal or categorical scale data. The second type of data is ordinal or ranking scale. As the name indicates, ordinal means it is associated to some ranking or order or sequence. For example, I can take say an individual and then I can assign this individual say a class label. The class label may be poor, fair, good or excellent. Now, the label poor, fair, good and excellent are in a sequence or in an order. So, we may be identifying which among that order or ordered categorical label need to be assigned to a data. So, this is what is called as ordinal or ranking scale data. Both this nominal categorical scale as well as ordinal or ranking scale, both are used for qualitative classifications only. The next two type of measurement scales are interval scale and ratio scale. Interval scale is fundamentally used for classifying the data in ranges. So, what we do is we can take a data and then we can split the data into ranges, and we can identify to which particular range the data actually belongs to. So, this is one type of quantitative classification. We can take time, temperature, etc., etc. We can always identify different time ranges, for example AM, PM, and we can take a particular time unit and fit either into an AM or PM category. Now, this AM and PM are two different ranges of values. For example, temperature. When we take temperature, we can have high, low range. So, high may be marked from the range of say 10 to 20 degrees centigrade, and low may be marked from the range of 5 to 10 degrees centigrade. So, these two ranges are example for interval scale values. Actually speaking, when we are trying to work with respect to an interval scale data, it is 0 point of scale which may be arbitrary in nature. For example, let us take say Fahrenheit. When you are representing the temperature in Fahrenheit and we say it is 0, it actually does not mean the temperature is 0. In other words, there is some kind of kinetic energy, molecular kinetic energy that exists, but we assign a scale or we assign a label called 0. But when we represent the same temperature in Kelvin scale, the 0 value actually has an importance. So, 0 point of scale is going to be arbitrary in nature when we are dealing with respect to an interval scale. The last type of measurement scale is ratio scale. In ratio scale, it is fundamentally we are taking a data and classifying it as the ratio of two numbers. So, what we can do is we can take two different parameters and we can use these two different parameters for providing a quantitative classification. For example, we can take height and weight, or height distance or weight distance. Accordingly, you can provide a ratio information and handle the data. Here 0 point of scale is going to be a real information. So, data can be added, it can be subtracted, or it can be multiplied. Some kind of arithmetic operation may be performed on ratio scale values. So, having understood the different types of data as well as different types of measurement scale, now let us start with univariate analysis. So, the first type of analysis that we can do is on single variable. So, univariate analysis, as the name indicates, also known as descriptive statistics, focuses on a single attribute at a time. Now, when you have a data, the data assume it is represented by a data matrix. Normally, any data may be represented in the form of a matrix. Only then we can provide the matrix for an algorithm for further processing. So, here also let us assume the data is represented in the form of a data matrix. When we are doing univariate analysis, the data matrix will be represented as, or may be visualized in the form of an n by n matrix, where n is the number of rows and 1 is the number of column. So, what does it mean? This univariate data may be represented as a single column vector, or the matrix contains exactly one column. Here the column will actually have values of the attribute, say x, that we are considering for analysis. So, x will be having various values and the cells in the data matrix will have the corresponding value of x. With respect to univariate analysis, what are the various measures which may be used for quantifying? So, the first measure which may be used for quantifying univariate analysis is range, followed by min max, average, median, mode, variance, standard deviation and histograms. So, the set of measures which may be associated to univariate analysis are given in this slide. Let us discuss each and every metric in detail. To start with, we will first discuss range. Range is fundamentally a difference between minimum and maximum values in a data set. For example, we can have a set of data like the one shown in the slide. So, we have set of numbers 73, 66, 69 till 100. Given this set of numbers, we can find what is the minimum and maximum value. So, in this set of values, 45 is going to be the minimum value, 100 is going to be the maximum value. Now, the difference between the minimum and maximum value is fundamentally called as the range. So, 100 minus 45, which is say 55, is treated to be the range of the given data set. Normally, when we have a wider range, what we think is, we think the variance or the spread of data is also large, but in all scenarios it need not be. We may have a larger range, but the spread of data may be small with respect to the given data set. The second type of metric is mean. Mean is fundamentally the average. When we talk about mean, we can take a set of data, we can sum all the values available in the data and divide the value, that is the sum, by the total number of values in the given data set. This normally generates average. It actually provides a one number summary about the location or the central tendency for the distribution of the variable x. So, if we are analyzing say a variable x and its corresponding values, we can identify where exactly the data tends to average. This is what is provided by the metric called mean. So, the equation for computing the mean or average is shown in the slide. So, it is going to be sum of the values taken by the variable divided by n, where n is the total number of values in the data set. For example, if there are 73 till 100 set of numbers, we can compute the average of these numbers by simply summing the numbers and dividing the total sum by the total number of values in the set. So, there are 20 values in this set. So, we sum all the numbers and the entire sum is divided by 20, which is equal to 68.6. So, 68.6 is said to be, say, the mean or average of this data set. Now, this number can be considered as, say, a one number summary, which clearly tells you the central tendency of the given data set or the distribution of the data x. The mean is actually also called as the expected value of a random variable, which is generated by means of its arithmetic average. So, the equation for the expected random value based on its arithmetic average is given here. So, E of x is nothing but the expected value of the random variable. Mu is the notation used for representing the metric called mean. So, this is equal to summation of, say, the variable with respect to its probability distribution function. Now, let us take two examples. In this example, there are 4 numbers and we find the average to be 4.8, and in the second scenario the average is 4.8. So, in both the scenarios we have the same average, but when you take a look at the distribution of data, we know that mean is going to be the central tendency of the distribution. So, it will be exactly in the middle. But when we take look at the data here in this scenario, the data on the left hand side and the number of data on the right hand side are almost equal, that is, they are spread symmetrically. But with respect to this scenario, though the average is in the middle, we may find less number of data spread on the left hand side and more number of data spread on the right hand side. So, what does it mean? The data that we are considering may or may not be symmetrical around its average value. The next metric is median. Median is fundamentally the middle value of the sorted data. So, when we have a set of data, we can always sort the data in some order and we can identify the middle value, which may be considered as the median. Now, when we identify the median, it means half of the value will be greater than that median and the remaining half of the value will be smaller than the median value. This is also another measure which is used for measuring the central location of a data set. So, in this given sample data set, this is sorted in ascending order and we identify the middle value. Since here are 20 numbers, we will be taking the middle two elements. So, 67 and 69 are the middle two elements, then we divide the sum of these two numbers by 2. So, 67 plus 69 divided by 2, therefore, the median is going to be 68. So, now 68 will be considered as the middle value in this sorted data set. Now, what is the application of mean and what is the application of median? Normally, when we are using a data and when we are trying to compute the variance of data with respect to its mean, there is lot of chance the mean may be wrong. The reason is, if my data is having lot of noises because of, say, typographical error or because of malfunctioning of the automated data collection tool, lot of erroneous or noisy data may be part of your data set. Now, if we compute the mean or the average, then the average will be oriented towards the noises only. So, what is that we need to do is, suppose we do not know about the quality of the data, instead of using average for any other computation, we can depend on, say, the median value, because median value when we sort, all the anomalies will be pushed towards the boundaries. So, if I have a smaller value, assume it is going to be a noise, then it will go to the left extreme. If I have a noise as a larger value, then that value will go to the right extreme. Therefore, the middle value will not be affected or will never be affected by these noises. So, when we are handling data without any knowledge about the quality of the data, it is good to make use of the median value for further analysis. Here also we can take an example. So, here in this scenario, the median is going to be, say, 6.5, but normally in analysis what we can do is, when we want to get better results, we can combine both mean as well as median for the purpose of defining to what extent the data is skewed or to what extent the distribution is skewed. Accordingly also we can choose a specific type of analysis and we can derive an outcome. The next metric is mode. Mode is actually the most frequently occurring value in the data set. This is another metric which is used for measuring the central location of the data. So, in this given data set, we identify 74 as the mode. This is done by identifying the frequency of occurrence of each and every values in the data set, and we find 74 is the value that has occurred often. So, here in this scenario 74 has occurred twice. Therefore, we consider the mode of the given data to be 74. Normally, mode may not convey more semantics about the data. If we are trying to work with respect to the percentage, even that might convey semantics, but mode often are not used for analysis. The next type of and a very important metric is variance. Variance is nothing but a measure which quantifies the dispersion of the data set. So, this dispersion indicates to what extent the data in my data set are deviated. Now, this is very much essential for analysis. For example, when I want to take a data and analyze it from a particular perspective, I should know whether the data exhibits the variance in that particular perspective or in that particular dimension. So, which metric will be used or may be used for the purpose of quantifying this is variance. So, how variance may be calculated? When we are trying to calculate the variance, we need to identify the average or the mean of the given data. Then we need to compute the difference of a specific data with respect to its average, square the difference and then sum all these squares. This entire sum need to be divided by the total number of data, which is n. So, as per this equation, compute the difference of every data with respect to its mean, square the difference, sum all the squared differences and divide the sum by n, which will provide you the variance. For example, for the previous data set, we can compute the mean. The mean is going to be 68.6, which we have discussed earlier. Now, take each and every data point from the data set. For example, 45 is one data point, subtract it with respect to the mean. The second data point 49, compute the difference of 49 with respect to the mean and so on. So, there are 20 values. For all the 20 data points, compute its difference with respect to the mean, square the difference, sum all the squared differences and divide it by the total number of data points 20, which is equal to 181. So, 181 is a value that will quantify to what extent, say, the data in the given data set are deviated. Larger the variation in variance indicates there is larger deviation with respect to the data that we have considered. The next metric is standard deviation. Standard deviation is derived from variance, so it is the square root of variance. Now, we can think about the standard deviation as an average deviation with respect to the mean of the data. The magnitude or the quantum of the number is nothing but, say, a variance with respect to the line of data in our given data set. Say, for example, we can take the same variance value and if you apply square root of that, we will get the standard deviation. So, either you can make use of, say, the variance or the standard deviation for identifying the deviation in terms of our data set. The next type of metric which may be used for analyzing the distribution of data is histograms. Now, where histograms are applicable? Suppose you have a very large data set and in the data set you find large data distributed over a varying scale. Now, if you are trying to analyze the data manually, it may be very difficult for us to understand the distribution. But if you represent the same data in the form of a graph or graphically, then the distribution and the statistics about the distribution may be well understood. So, what I am trying to say here is, when we are trying to deal with a very large data set and when we want to analyze the distribution, better use a chart or represent it graphically. Now, when you represent it graphically, even there you may find certain difficulty. The difficulty may arise because of the number of values that you are dealing with. If suppose I am going to handle, say, 1 lakh values, it will be very difficult for me to plot it on a sheet or to visualize it in the form of a graph. In such scenarios, what is that we can do is, we can categorize the data elements into categories or ranges, then identify how many elements belong or fall in that range, quantify it. Fundamentally, we are trying to identify the frequency of data elements in various categorical ranges. then you can make use of this categorical range for plotting a graph. For example, assume this is say a graph and we are dealing with say 20 values in the data set. Now if I plot this in the form of a graph, we may end up with a bar chart like this. But with this bar chart even, we need to analyze each and every line for identifying which one may be the minimum, which one may be the maximum value. Accordingly, we need to derive the average or the range, or sometimes we want to calculate the variance means, then we need to compute the difference of every value with respect to the average. So from this chart itself with the 20 values, we are not in a position to do the task. So when the number of data increases, of course this chart becomes too complex. So in such scenarios, what is that we can do is, we can actually come up with a frequency table. This frequency table will highlight the various categorical labels. For example, we can split in ranges like 0 to 50, 51 to 60, 61 to 70, 71 to 80, 81 to 90 and greater than 90. Then we can take every data, assume this is the data that we are handling. Now I have come up with various categorical labels. Identify each and every data and check to which particular category does it belong to. For example, let us take the first data 45. Now when we verify in the table, we find it belongs to the first category, that is 0 to 50. So now set the frequency to 1. Then take the second data 49. This data also belongs to this categorical label, therefore set the counter to 2, that is increment the counter by 1. Likewise, take each and every data from this data set and then identify to which category it belongs to. Accordingly, you define the frequency. Now I have got a set of categories and the frequency of occurrence of data points in these categorical labels. Now this may be used for the purpose of defining a chart. Now when you take a look at this chart and the chart that we viewed earlier, you may find this chart which is developed based on this frequency table seems to be bit simple and easily understandable. The reason is we have put the data points into different types of categories and accordingly we have identified the frequency of occurrence of data points in these categories, and it is this frequency which is plotted in this graph. Now this graph or this bar diagram is called as an histogram. So what exactly is an histogram is, a histogram is simply a column chart of the frequency table. This may be useful when we want to identify which particular data element has occurred in majority. Let us take say a text database environment. When you want to identify what are those set of terms or keywords that often occur in say the web documents that is available in your database, then we can take all possible keywords available in the web documents, sort them, put them into categories. Say for example, all keywords beginning from A till C, then all categories or keywords starting from D till say S, then all labels beginning with alphabets say T till Z. Now we have 3 categories. Now we can take each and every keyword, identify to which particular category does it belong to. Accordingly, we can develop a frequency table, and when that frequency table is plotted in the form of a column chart, will provide you a histogram. So this histogram will help you in understanding the distribution of data elements which is part of your data set. So in summary, in this module we discussed about the importance of measurement in analysis. If the measurement of data is correct and the type of data is identified correctly, then only analysis will be correct. We discussed about 4 types of data: univariate and multivariate data, and the second type of category cross-sectional and time-ordered data. Understanding the type of data is also very essential for analysis. And the last point that we discussed and analyzed is, we should know what type of measurement scales are there. According to the type of measurement, we need to identify what data are we handling, and accordingly a specific type of analysis need to be taken into consideration. Whether it is say univariate or a cross-sectional or a multivariate or a time-ordered data, whatever it may be, we should also know how many variables are we going to make use for our analysis. If you are going to make use of exactly one variable, then it is called as a univariate analysis. And finally, we discussed about the various metrics which may be used for quantifying univariate analysis. Thank you.